Hey everybody, this is Larry. This is me over Q3 of the weekly contest 452 with a spoiler alert. Minimum moves to clean the classroom. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I mean, a lot of Leetcode problems, especially this contest, I already said that, look at the constraints. You always have to anyway. So think about it with the constraints in mind. You don't have to prematurely optimize anything. And the thing that jumped out at me, well, the classrooms are small, but also there's at most 10L, right? Because there's 10L, and you kind of want to do basically trials. Is it traveling salesperson? It's kind of, I forget if that's, it's not Hampath. I forget if it's, oops. But yeah, it's just traveling salesperson, right? You have to visit all the L's, maybe visit some R's along the way or whatever. So as a result of that, once you realize that, because you have to collect all 10, you know that, well, in the general case, this is NP, right? Or NP complete or NP hard. I always forget which one's which. All I know is anything with NP is hard enough for me. But as a result, that means that you can only solve it with dynamic programming, shortest path, etc. But something that will allow you to solve it in pseudo polynomial or something like that, right? But something that its NP is hard. So yeah, and because there's 10, the thing that in my mind is that I can do something like 2 to the L, 2 to the 10, right? Because 2 to 10 is 1,000, and all the other constraints are small enough, so I thought it was good. And there's also an energy in there as well. I did a very basic math with energy, and it's just like 400 times 50 times 1,000. It's 20 million, which is a little bit high, but I thought it maybe there are a lot of states it's not possible, and we can just go, right? Yeah. Yeah, and that's it. And basically, that's basically how I set it up. And we'll go over the code. And for this one, first we parse the map. We find the starting point of the student or whatever. We find all the litter in IJ. And the reason why we have that is just that so that we can put in a lookup thing, so that now it looks up from a number to 1 to 10 or 0 to 9 to be more precise, right? So this will come in later, maybe, right? And then ending is, of course, if we visit, L is the number of things that we have to pick up, and this is just a bit just a shorthand for a bit mask. So I have to do this thing where, for an optimization purpose. So let's going back here. You see that I have 4 wrong answers, and honestly, the reason is because time limit exceeds, and I had to do some like weird optimization. But the thing with Leetcode is that you never know if you need to do more optimizations or not. So it is what it is. I got 4 wrong answers. And also, for those of you who wonder why I do not do Leetcode contest live anymore, this is why. Because Leetcode is really bad at setting constraints, and there's no way for me to debug, so that now my rating or whatever just becomes RNG anyway, right? Anyway, that's another rant. My apologies. But yeah, so I did this thing where if the graph is not possible, I return -1. And this is like a very cheap impossible filter, right? It just basically saying, okay, if all the L's are not connected to you, then return -1. So that's just like given that it's 20 by 20, this is a really fast-ish, even for the biggest graph. It's just like, if it's not possible, then we do -1, so we turn -1, so then we don't do the rest of the expensive things, right? And the expensive part is not, basically, if you think about it in terms of similar to like dynamic programming or something like that, you only have these states. You have where you are, X and Y. You have energy, which is how much energy you have now, and bit mask. Bit mask, I think I talk a lot about bit mask these days because it just comes up a lot. But bit mask is just really, you can think of it as a bit vector, right? And what's a bit vector? It just means a list of bits, right? And what I mean by that, and Leetcode keeps on messing up all my things now, is that if you have a list of bits, then you just have like 1 and zeros, right? And then for here, maybe you could just treat ones as that you collected that leader. For example, this is the third Leetcode highlighting also changed today, so I don't know how to highlight this to show you. But let's say you're doing the third one, that means that the third letter we picked up already. So that's basically how we just keep track of this. You can think of it as a Boolean vector, if you will. But yeah, but we just kind of, everyone just become breadth first search, and that's it. It's a breadth first search on these 4 states. And yeah, and like I said, and everything is very breadth first searchy. Yeah, which is like this doesn't. There's so much room that I'm missing because of the code. I don't know. But in any case, yeah, you started your starting point, starting X, starting Y. Energy is the initial energy. We haven't collected anything, so it's 0. And then this is just the distance, which is 0 because it's the beginning. And we set up the distance here. And then this is just a regular BFS afterwards. A little bit more confusing, but mostly a straightforward BFS. You just have to make sure that your graph transition, your edges are correct, right? So here we have this thing. If the bit mask is the ending, then we return the distance because that means we're done. If y is equal to 0, we're done because we have to consume 1 to move off. Otherwise, yeah, because the reason why I did it this way, and I debated a little bit, is that when we move to a new space with energy, we collect for energy there. It just makes it, I think it makes it a little bit faster, but I may be wrong on that one, so don't quote me. But in any case, yeah, and then just dx dy, go to the new cell, make sure that the cell is within the constraint. If the new classroom is an X, meaning that is an obstacle, then don't go in, then we skip it because we can't go into it. Otherwise, we consume energy, and this is an R. If it's an R, then we make the next energy to be full, so we set the energy, right? Bit mask, as we said, this is just all the letter that we picked up. And so if we move to a cell where there's an L, that means that we pick up that letter. So that's why I've just looked up here. And this is an OR statement, so we already picked it up. We just kind of, we just already picked it up. And then now we just check in a regular BFS kind of way. We just check that we haven't visited this yet. If it's not a distance, then we check. If it's the ending, we just print d+1, but for search stuff. Otherwise, we update distance, we update the queue, and we are good. And at the end, we return -1 if nothing else is good. And we can find our way to the ending, which is collecting all the litter, right? Because we only check the bit mask. The other things don't matter at the ending. And that's it. That's all I have for this one. Yeah. What's the complexity here, right? Well, we kind of talked about it. In theory, a lot of these things are not possible, but maybe they are because you can have a lot of R's to reset the energy. So it's going to be, these are the number of states, and for each state, we go in 4 directions, right? So it's going to be this times 4, which is 20 times 20 times 50 times 1,024 times 4, if you will. And it's a big O of that. And that's the space as well because we use it both for distance and queue. And that's it. That's all we have for this one. Oh, and yeah, and this, I already talked about this, but this is just a regular, like an actual regular BFS to see if everything is reachable, right? So if we cannot reach a certain letter, we just return false. And that's it. Now, let me show you the code one more time. This is the top. This is the possible code. And this is the BFS. Slowly scrolling down. And then while loop, second half. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live during the contest now. Yeah, I just did a lot of optimizations. I don't know that. I mean, everything I thought was pretty straightforward for this one. So yeah. The contest. So this is like, they usually fix it afterwards, but it takes a bit. We'll see. Okay, so you have an M by N grid. Get some candy again. I just, okay, I gotta stop eating candy. I'm gonna just get big. All right, you have a cleaning up later. Each cell. Oh, the classroom is a string. All right. All right. You have only one student. Leader must be collected. I'm going to constrain room is very small, 1S, at most 10L. Is that, I don't even know what the rest of the problem is, but it seems like it's some kind of traveling salesperson problem type thing, just by the constraints. Maybe TP, but with the same idea. Okay. So you can go to R multiple times. No obstacle, empty. Okay. Is it Dijkstra? It's not travel. It's not Travel's person. It's actually Dijkstra, I think. Okay. I don't want to write it. 400 times 10. I guess that's fine. Okay. Yeah, okay. It actually turns out to be Dijkstra. Many resets, right? Yeah, it doesn't say. Actually, I made some assumptions that there might only be. I see. Okay, I guess that's fine. I see. It's a breakfast search problem. I thought. No, was it? I thought if there's like not that many R things, I could just put down the Dijkstra, but because of the R, or like they could be all R's, then it's just easy, right? As an example. How's the 3 liter? Or the leader. We didn't need to go to R. Weird one for sure. What is Q for? Is a 7-pointer, so I should figure this out. How do I handle R? If there's no R, it's just straightforward. Oh, I see. XY was at 400 times 50 times 1000. Is that too slow? That seems too slow. Or maybe a lot of the states are not possible. 200 minutes. This is so stupid. I have to gamble that a lot of the states are not possible. I guess a lot of states are not possible because of X. How do you handle this one? Yeah, okay. Okay, fine. Yeah, whatever. Okay. Okay, yeah. Getting a little distracted. Yeah, this should be fine, but we'll see if it's fast enough. 2,000 moves at most. Maybe. So we want to say SX, SY, 50 energy, or not 50 energy, energy, and then mask of 0. And this is going to have the distance of 0. Right? I don't know how I feel about this one, to be honest. Oh, this should be whatever ye. What is 0 again? Oh no, that's just it. Only have 4 things. Okay. I'm gonna do something about. Okay, maybe something like. Yeah. Oh, that's why, because I forgot the D. Okay, and then now, if it's within bounds. I mean, this isn't that bad, but it's just annoying. Assuming that it doesn't time out, which Leetcode, who knows? Quit? No, it's close. Why is... I guess I have to do an if statement on that, actually. Okay. So then now we do a switch statement-ish. I just do keep it if. Continue. If okay, so then now if x and y and the is in I have to do one more optimization, I think, but oh, I didn't put D+1 here. But let's see if it runs real quick. I had to click on this. Why do you make me click on this? Okay, well, I mean that's wrong anyway. But why? Tell me why. I keep doing that, but yeah. I mean that doesn't do anything. It's just an optimization. Why is it -1 though? S6 SY. Let's see. Oh, I didn't even handle energy correctly actually, but so this was going to be wrong. But it shouldn't be -1. It should just give me an answer. Actually, that's nice that they finally separate that out for me, unless I did it by accident. But a 00 Y bit mask ending. Actually, also. Okay, so they have to go from 1 to 0 for the energy stuff. Okay, but we still don't have this though. It's weird. I did the bit mask wrong. Or the okay. So D it goes 0 1 0 2. Energy didn't change. Bit mask didn't change. D Y. Oh man! Oh no! Lookup is the index. So actually, okay, I'm dumb. I kind of was thinking about it, but I thought I might have pre-processed it. Okay, 2, 3, and 4. Y4. Not all valid paths. No valid path contains OL. Why not? Just down is 1. Oh, okay. 1, 2, 3. 1, 2, 3. Okay. Oh yeah, I didn't do energy. Okay, that's fine. I knew that I needed to do energy anyway. If new energy is greater than new 0. Okay, so that looks okay. Did I print anything? 2, 3, 1. YOLO submit. Maybe close. Guess we'll see. Maybe it times out. That'll be sad. Oh, wrong answers. Actually, even more sad. Let's see. Expect a -1. I put 3. Maybe I'm off by 1 though. Energy is 1 is probably off by 1. I go S. I go 1. It goes to 0. Oh, because this is 0. I see. I am off by 1. Okay, how do I handle this? Because I count the energy first, right? Okay, let's actually don't reset when we go in. Just check that this is -1, and then we check it here at the beginning. If classroom of xy is equal to r, then and y is equal to, I mean, maybe y is equal to energy is fine actually. -1, okay. YOLO submit. Please no silly mistakes like that one. Also, don't time out. I never know where to look to when after I click on these things anymore. It's like so many things to look. Time limit exceed is not great. 96 out of 799. I feel like it's a Python thing, or Leetcode silliness about Python. Do they not give you the timing anymore? They give you less time to, come on, Leetcode. They give you less results. Are you serious? Like, here's the running time. Okay, fine. I don't know. Leetcode is so bad. I don't get it. Like, I used to defend them so much, but they just keep on doing things. Like, do you use your product? I don't get it. Okay, fine. Let's see. Like, how do I want to write this? What's that? Let's see. I think for it reduces state if I write if e is equal to 0, then we're done with this one. And then here, that means that e is not equal to 0. Then if classroom of nx and y is equal to reset, then ne is equal to energy. Maybe that's a little bit better. Yeah, it looks a lot faster for that case. Because we terminate now, and also now NE will never be whatever. All right, YOLO submit. But like, that's a like how do I? There's no way for me to know that's a good enough optimization, right? We made it 80% faster or whatever, and we did 2 more test cases, but there's just no way for me to know whether that's fast enough. So this is another Leetcode thing, right? And now I'm cheating, if you will, by asking ChatGPT to just convert it for me. Thing is that, like, I don't know, maybe this is full, so then, you know. Like, maybe this is full, like, I don't know, like, if I convert it to an array, would it be fast enough? Unclear. So, I don't know. Okay, let's see. Lookup is, what is going on? I just want to look up to look up and to an int. What is all this? Oh, this is the hash. I don't need it. GPT is being weird. Just use unordered. What? Oh, use ordered. Oh, just map, I think. It's been a while. I don't use C++ enough. This is too slow. This feels too slow, though. I mean, it takes just as long as the Python one. And some of it's because, you know, I'm not really doing this right. I think tuple is probably a bad idea, honestly. Is that not right? And the thing is that, like, I can't tell, like, with these problems, I could never tell if it's Leetcode. It's because the constraints are so dumb that, you know, like is it me? Is it Leetcode? Who knows? I just flip a coin to see whether I get AC. Yeah. Like, is this fast enough? Doesn't look so, to be honest. But YOLO submit, maybe it times out. Maybe it gives me a wrong answer because I didn't even look at this, right? Yeah, and so I don't know. Maybe it is just slow, just slightly too slow, right? But how can you tell when your submission is? Thanks. It tells you 5-minute penalty. Like when you do 788 of 89 cases, is it, you know? How much time do I have left? Doesn't even say because okay, 58 minutes. Can I optimize this? X, if it's R, if it's L. I mean, I don't get it. What is the test case status? There's a lot of resets. I think that's the worst case. Can I reduce the rest case? Because I think that's the thing that gives me too much energy, so it increases states by a lot. Maybe that should be okay, right? How many states do I hit? I'm eating too much candy. I gotta stop eating candy. 103. Why does 103 states take so long? Am I doing it wrong? Oh no, that's the output, not the print. Oh, because I print here. Okay, yeah, that makes sense. Let's print here. Like I'm doing silly optimizations. Okay, 800,000, a million, so they're pretty bad. Can I reduce them? Oh, because I see, because I go back and forth. So then it does, I was thinking that a lot of the states should not be reachable, but if you go back and forth, then your new energy, right? So I see. So how can I fix that? I fixed that by, is it, no. Okay, so can I store the max energy? So, okay, so you have energy. So the trade-off is that the more energy you have, right? Trying to reduce this. And it may be that in Java is fast enough, to be frank, but I feel like you can reduce the energy, but yeah, maybe we can do something like that. No, because then you could come back with more moves with more energy. I see. Yeah, that's why I didn't do it that way. Because you could come back with more energy, but more moves. So, in theory, the lower energy means that you have fewer moves. So it's not. So then you could come back. Can you come back? No, you wouldn't come back to the same way because you have more energy but more moves. So then it's monotonically increasing. Should I go ahead? I mean, people's gotten in 2 minutes, but that's probably cheating. But I wonder if it's worthwhile to just, like if it is not connected, then we just remove them. I mean, I don't think it does anything though, but I guess it's free. Let's do it. So then we don't do extra work on those because Leetcode is stupid. Okay, fine. Right, so then now here. I mean, this is such a linear optimization, right? That it doesn't even make sense for me to do it. But I don't have any ideas, frankly, other than, you know, cursing Leetcode, which is not going to solve me a problem. I don't think. This is the case. Now just do if n what's it called? Classrooms. Classroom. Okay, then we just go. Where? Oh. I don't know if this. It's still going. It looks like it takes a while, even longer than before. So maybe it's just Leetcode having issues. Oh no, it's this new code. Oh yeah, whoops. Okay, that is not Leetcode's problem. That's just me being dumb. That's the thing, right? Is that when you don't trust the platform, you know, like all these things can happen, right? Did I print stuff? Seems like I print stuff. I print distances. Does it help? I don't know. Probably not enough, but may even hurt it, to be honest. But I don't really have ideas because you have to reduce. Okay, so like that is just stupid, right? I don't know. We're 15 minutes. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the explanations, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.